Before getting started on the calibration procedure, let's take a minute to understand what it is we're doing. How does the SmartExtruder apply sealant? First, we have a hot melt pump station that heats the material and pumps it through a hose to the extruder. That material goes into the gear pump, which regulates the flow of sealant to the extruder manifold and to the side and bottom head. The side and bottom nozzle tips are adjusted to regulate the flow of material onto the spacer as it passes through the heads. This is the gear pump the GED SmartExtruder uses to apply sealant and matrix to the Intercept Spacer Frame machine. The material enters the gear pump through this larger port, fills the teeth of the gears, and as the gears rotate and mesh together, the material is forced out the exit port. Each revolution delivers 20 cc of material to the extruder. The variable frequency drives, located in the back of the electrical cabinet, regulate how fast the gear pump turns, and thus how much material is delivered to the extruder. What we will be doing in the Calibration Wizard is calibrating the speed at which we run the gear pump and the flow of the material through the nozzle tips, so we put on precisely how much material we want at the desired operating pressure. Before getting started, you should verify a few things that can adversely affect the calibration process. Verify the nozzle tips are not worn. The distance from the face of the nozzle tip to the bottom of the channel forms a bead's profile. If the nozzle tip is worn, it may be difficult to achieve the desired application. Make sure the conveyor belts are tight and not slipping. Make sure the hold-down wheels are not worn to the point where they're not applying proper hold-down pressure. Insufficient hold-down pressure due to worn wheels or improper wheel height may allow the spacer to slip slightly, affecting the sealant application. Jog a spacer through the machine and check how it tracks through the conveyor guides, the matrix nozzle, and the side sealant nozzles. The conveyor guide should be about 20 thousandths of an inch wider than the spacer to prevent any wandering or binding. The matrix nozzle tip should be centered in the spacer channel so it doesn't deform the spacer or wear the nozzle tip. If the spacer veers left or right as it travels through the side sealant nozzle tips, this is an indication that the conveyor guides and side heads are not aligned, or the hold-down wheels are steering the spacer. Extruder setup and alignment is covered in GED document APN 0099. Additionally, verify that steps 1 and 2 of the Calibration Wizard have been run by verifying the conveyor speed and the home offset. Prior to running step 3, go to step 2 and home the side sealant heads and then move them to the desired spacer size. Typically, it is best to use a mid-size spacer from the spacer sizes you run, or whatever size is most common. It is important to know that steps 3 and 4 must be run together on a standard, non-co SmartExtruder in order to balance the side and bottom application pressures. When running step 3, you will be calibrating the side sealant application, which is dependent upon the frequency setting of the gear pump as well as the conveyor speed. In step 3, you are instructed to first close the side nozzles and open them 1 1/4 turns. When closing the side head stroke adjustment screw, do not tighten, as this will damage the stem and the seat. Also, being meticulous, count the number of turns in. This should be less than 3 turns. If the heads are already in service and open less than 3 turns, then set them back to where they were. This will likely shorten the process of running this step if you only have a slight adjustment to make. If the heads have just been rebuilt, or if they were open more than 3 turns, then open the heads 1 1/4 turns. Do the same to the non-operator side. Count the number of turns to close, then open the head back to the same position if the head has been in service and was open less than 3 turns. Open the head 1 1/4 turns if it was just rebuilt, or if it was open more than 3 turns. Once the side head openings are set, press the sealant test button and start the conveyors. Pressing the up or down arrow keys changes the frequency settings of the drive for the side heads. Later versions of WinExtrude software have a display showing the side head bead thickness, as seen here. While this value should be close to what is measured, it may vary slightly as it's calculated based upon the frequency setting and the conveyor speed. Run a few spacers through the extruder and inspect the bead. Sealant should completely fill the channel of the nozzle tip, and the excess should push out the top and bottom of the channel, creating a thin layer of material above and below the bead, as we see here on the operator side of the spacer. The non-operator side of this spacer is very thin, with no excess material above or below the bead. You normally want to press the up and down arrow keys until you get a good-looking bead before you start to measure the bead height. In this case, I have a good-looking bead on the operator side, but not on the non-operator side. Using the techniques described in the Measuring the Sealant application video, measure the thickness on one side. I usually start with the operator side, which in this case is a full profile side I want to measure. I measured 73 thousandths on the operator side and 40 thousandths on the non-operator side. Normally, I would continue to increase or decrease the frequency setting until I had the desired amount of material on the operator side. But since the sides are not balanced, I will work to even them out. I can either close the operator side to force the material over to the non-operator side, or I could open the non-operator side to draw material over from the operator side. The typical operating pressure should be between 600 to 1200 psi, so I typically shoot for mid-range around 900 psi. Opening the heads will lower the pressure, while closing them will raise the pressure. Since my pressure is low, I will close the operator side head a quarter turn, which will not only force the material to the other side, but also raise the pressure. The pressure came up, but the sealant is still heavy on the operator side, so I've closed the head an eighth turn this time. The pressure went higher than I wanted, and my non-operator side is still thin, so I will open the non-operator side head an eighth turn to lower the pressure and divert more material to that side. Again, the pressure is still a little high, and the non-operator side is thinner than the operator side. So I open the non-operator side about another eighth turn. Now the pressure is good, let's check the thickness. The beads are nearly even, 55 thousandths on the operator side and 56 thousandths on the non-operator side. The sides are even and the pressure is good. I'm in a good place, but before continuing to step 4, document your current side head settings. When you have completed running these or any other calibration or setup procedures, it's highly recommended that you back up your parameters. Carefully loosen the jam nuts on each head and meticulously count the number of turns as they are closed. Open them back to exactly where they were, lock the jam nuts, and document the head settings. Having your sealant head settings from when your backup is made will make restoring the machine to its last saved calibration position much easier and will reduce downtime. Once again, verify all is good. Then press the side head's calibrated button to carry the side head pressure to the next step where it is needed to run step 4. This version of When Extrude adds 50 psi to the side head pressure, and this becomes target pressure for step 4. Older versions just display the side head pressure. Step 4 will calibrate the material applied to the bottom of the spacer, which is dependent upon the frequency setting of the gear pump and the conveyor speed. As in step 3, close the bottom head, counting the number of turns. Again, do not tighten the stop bolt, as this will damage the stem and the seat. This nozzle was open 3/4 turns, so I'm going to set it back to where it was because the head's been in service. Again, if the bottom nozzle was open more than 4 turns, or the head was just rebuilt, then I would have set it to about 2.5 turns open, which is the default opening for a 50 thousandths thick bottom application. Remember, the maximum number of turns on the bottom is 4 turns, while the maximum on the side is 3 turns open. Opening more than the maximum is not controlling the flow. Instead, the material will follow the path of least resistance. Typically, the bottom thickness should be between 30 to 50 thousandths, ideally around 40 thousandths. Press the sealant test button after you've entered the desired thickness. Too much material on the bottom creates handling issues, and the sealant may stick to the belt more. For this amount, 1.5 to 2 turns open is generally a good starting point for the bottom head. Measure the bottom sealant thickness and enter it into the measured thickness box. In this case, I measured 48 thousandths, so I'm going to enter that value in the measured thickness box. The software will look at the current pressure and the material thickness and run the information through an algorithm which will tell you what to do next. The software has automatically decreased the frequency drive because I have too much material on the bottom. And since the current pressure is low, I'm instructed to close the bottom head in 8th turn. I've closed the sealant heads, acknowledged the message, and press the sealant test button to run a few more spacers. Measure the bottom sealant thickness again and enter it in the measured thickness box. I measured 40 thousandths, so the frequency drive did not change. But my pressure is still low, so I have to close the bottom nozzle another 8th turn. I will acknowledge the message and run a few more spacers after closing the head again. This time the bottom measured 34 thousandths. No nozzle adjustment this time, but the frequency drive increased since my material is thinner than my desired amount. I will press the sealant test button, run a few more spacers, and check the bottom thickness again. This time the bottom measures 38 thousandths. The message displays that my sealant pressure and bottom thickness are within acceptable range. This means the current pressure is within 25 psi of the target or side head pressure, and the measured thickness is within 2 thousandths of the desired thickness. These criteria have changed since earlier versions of software because it has been determined that the current pressure should always be slightly higher than the side head pressure in Step 3 on a standard non-co-extruder. No matter what version of software you have, as long as the current pressure is higher than the actual side head pressure from Step 3, the thickness is within 2 thousandths, and the message is displayed that you are within acceptable range, then you may press Yes and accept settings. If you have an older version of software, and your current pressure is lower than that from Step 3, then press No and continue until everything is within acceptable range and the current pressure is slightly higher than the side head pressure. Document your bottom head opening setting. If unsure, count the number of turns in and set it back to where it was. Run another spacer, and if the pressure and thickness are okay, then do nothing more. If the pressure and thickness are slightly off, then enter the measured thickness and continue the process until all is acceptable. If we look at the material pump setup screen, by running steps 3 and 4 we have calibrated the side and bottom sealant applications respectively for the selected spacer size. By pressing the Make All Sealant Spacer Sizes Equal button, the software will make the application the same for all spacer sizes. Press the Save Pump Settings button to save these changes. You should also verify that the pressure set point for the sealant is acceptable. Typically, the pressure set point should be equal to or slightly higher than the steady state pressure. If necessary, change this value for the selected spacer size, make all sizes equal, and then save the pump settings. Back up your parameters.